Hello everybody, welcome into another lesson. So today we are going to talk about ratios of areas and volumes. So when we were on the 2D geometry unit, we talked about ratios of perimeters and areas. This lesson is sort of similar, but it brings in ratios of not only perimeters, but it brings in lateral areas, surface areas, and even volumes. This theorem here states that if the scale factor of two similar solids is a to b, which I gotta say, we know that there are similar polygons and similar circles, you can also have similar solids. That is actually a thing in the 3D world. So if the scale factor of two similar solids is a to b, then part one of this theorem is the ratio of their perimeters is a to b. So if you're trying to find the perimeter of the base, so you can find the lateral area or find the circumference of a cylinder or a cone to find the lateral area of those, the ratio of the perimeters is a to b. Now part two, the ratio of the base areas, lateral areas, and surface areas is a squared to b squared. So like in the last lesson, if your scale factor was a to b, your perimeter will be a to b. We even knew that the area itself would be a squared to b squared. That includes not only the base areas for your polygon or circle, that includes the lateral areas and the surface areas too. And then the new part, part three, is the ratio of their volumes is a cubed to b cubed. That's because, of course, volume is always in cubic units. So you would take each part of the scale factor, raise it to the third power, you get a cubed to b cubed. So we're going to do a few exercises here. This shouldn't be terribly long. So I have 6 exercises. So these are about similar cones. All 6 of these exercises pertain to similar cones. So for the first one, you have a scale factor that is 3 to 4. So you got a scale factor of 3 to 4. We need to find the ratio of base circumferences, which I'm going to abbreviate as the ratio of C, ratio of circumferences of each similar cone. Well, since the circumference is a perimeter in its own right, it's going to be the same as the scale factor, which is 3 to 4. They're also going to ask you to find the ratio of the slant heights, which I'm going to abbreviate lowercase l for being slant height. Well, since the slant height is just simply a length of a cone, that means it'll be in the ratio of 3 to 4. Now, here's where it changes. What about the ratio of the lateral areas? If we're asked to find the ratio of the lateral areas, that's where you take each part of the scale factor, raise it to the second power. So that'll be in the ratio of 3 to the second power to 4 to the second power, which in short would make the ratio 9 to 16 for the lateral areas. And then it's going to ask for the ratio of the surface areas. So the ratio of the surface areas, again, area is area, so it's going to be the exact same as that of the lateral area. There's a shortcut for you. If you found the ratio of one of the areas, all the other areas are the same. It'll be 9 to 16. Now, last but not least, what about the ratio of the volumes? Let's find the ratio of the volumes of these two similar solids. That is where you take each part of your scale factor and raise it to the third power. So it's going to be 3 to the third to 4 to the third for your scale, for your ratios, which in short would be 27 to 64. So your scale factor is 3 to 4, which means the ratio of your base circumferences is also 3 to 4, and the ratio of your slant heights would also be 3 to 4. Now the ratios of your lateral area and your surface area would both be 9 to 16, because you take each of your parts of the scale factor, set it to the second power. And then the ratio of your volumes would be 27 to 64, because you'll take each of your parts of your scale factor, raise them to the third power. And I got 5 more examples here. Alright, we'll do this. Okay, what is the next problem all about? The next one gives you a scale factor of 5 to 7. So you have 2 similar solids with a scale factor of 5 to 7. From there, we need to find the ratio of the base circumferences, which is a perimeter. So that means the ratio of the circumferences would also be 5 to 7. What about the ratio of your slant heights? Well, since it's just the length of the cones, it's also going to be 5 to 7. Alright, so there's that. Now we're getting into area. Remember, when you deal with area, you take each part of the scale factor and raise it to the second power. So it'll be in ratio 5 to the second power to 7 to the second power, which in short would give you 25 to 49. So the ratio of your lateral areas of the cones would be 25 to 49, which means the ratio of your surface areas would be the same, because area is area as far as ratios are concerned. So the ratio of your surface area would be 25 to 49. Now, what about the ratio of the volumes? Well, to find the ratio of the volumes, you take each part of your scale factor, raise those to the third power. So it would be in the ratio 5 to the third to 7 to the third, which I know 5 to the third is 125, but what is 7 to the third? That'd be 343. So you would have the ratio of volumes would be 125 to 343. All right. This changes a little bit now. All right, what do we got here? So this time they give you, to start with, the ratio of the base circumferences. You start with the ratio of the base circumferences, which would be 2 to 1. You still have to find everything else. The first thing you always want to find is your scale factor. Well, if you have the ratio of the circumferences being 2 to 1, that's basically a perimeter. That would be the same as your scale factor. So the scale factor would also have to be 2 to 1 if that's the ratio of your circumferences. The scale factor itself would have to be 2 to 1. So then what about the ratio of the slant height? What if we wanted to find the ratio of the slant height? That's the same as your scale factor. That would be 2 to 1. Alright, so we found those. Now what about the ratio of the lateral area? Now we're moving into area, so to find the ratio of those, you take each part of your ratio, raise it to the second power. So it would be in the ratio of 2 to the second power to 1 to the second power, which would simply be 4 to 1. So the ratio of the lateral areas would end up being 4 to 1. Which next you're asked for, what about the ratio of the surface areas? So we're going to find the ratio of the surface areas. Well, again, as far as ratios are concerned, area is area. It's going to be the exact same as that of the lateral area. So the ratio of the surface areas would also be 4 to 1. Now what about the ratio of the volumes? So let's find the ratio of the volumes. That's where you take each part of your scale factor and set it to the third power. So it would be in the ratio of 2 to the third power to 1 to the third power, which would simplify into 8 to 1. So the ratio of volumes between these two similar cones would actually be 8 to 1. Alright, I got 3 more problems. Whoops, I did not mean to erase the similar cones. That's okay. Only 3 more problems. We're about done. This time they start off giving you the ratio of the slant heights. They give you that the ratio of the slant heights is going to be 1 to 6. So the ratio of slant heights is 1 to 6. Well, again, I'm going to suggest that we find the scale factor first. Well, if the slant height is simply a length of the two cones, that means your scale factor would also have to be 1 to 6. So you have a scale factor of 1 to 6, which means now we can find the ratio of the base circumferences, which, since the circumference is basically a perimeter, that means the ratio of the circumferences is also 1 to 6. Now, we're going to next find the ratio of the lateral area. The ratio of the lateral area is, again, you take each part of your scale factor, raise it to the second power, so it'll be in the ratio 1 to the second power to 6 to the second power, which would simply give you a ratio of 1 to 36. So the ratio of lateral areas would be 1 to 36. Now, we're going to find the ratio of the surface areas. Which, again, for ratio sakes and scale factors, area is area, no matter what. It's going to be the same as that of the lateral area, which would give you a ratio of 1 to 36. And then, last but not least, we need to find the ratio of the volumes. Which, for the ratio of the volumes, you take each part of your scale factor, raise them to the third power. So they'd be in the ratio of 1 to the third power to 6 to the third power, which would simplify into 1 to 216 for the ratio of the volumes. So the ratio of the volumes for the two similar cones would be 1 to 216. Alright, 2 more problems. It's a little bit different this time, though. I don't know why I keep erasing that part. So we have 2 similar cones, but this time they start out giving you the ratio of the lateral area. The ratio of the lateral areas is 4 to 9. So the ratio of the lateral areas is 4 to 9. Now, they do ask you for the ratio of the surface areas also. So the ratio of the surface areas would be the same as that of the lateral area. It would also be 4 to 9. So the ratio of the surface areas is also 4 to 9. Now from there, we don't have a prayer of finding anything else until we find our scale factor. So let's look at it this way. If the ratios of area are each part of the scale factor squared, that means the scale factor itself would have to equal each ratio, it'd have to equal the square root of each part of the ratio of the areas. So it's going to be equal to the square root of 4 to the square root of 9, which in short would give you a scale factor of 2 to 3. So now we've identified our scale factor to be 2 to 3. We can find the ratio of the base circumferences, which is, since it's a perimeter, it would be the same as your scale factor of 2 to 3. And then we can find the ratio of the slant heights, since it's the length of the cone, which it would also be the scale factor of 2 to 3. And then, last but not least, let's find the ratio of the volumes. The ratio of the volumes, of course, is each part of the scale factor raised to the third power. So you would take 2, raise that to the third power, to 3, and raise that to the third power, which would simplify into 8 to 27. So the ratio of the volumes of these two cones would be 8 to 27. Okay, one more problem, and then we're done. So let's see here. If we do that, what do we got this time? We have, wow. They start out this time with the ratio of volumes. So right away they give you the ratio of the volumes to be 8 to 125. So all we know to start with is the ratio of the volumes is 8 to 125. Well, I would say we need to find the scale factor before we find anything else, right? So if the ratio of volumes is each part of the scale factor raised to the third power, that means that the scale factor would have to be the cube root of each part of the ratio of the volumes. So the scale factor would be equal to the ratio of the cube root of 8 to the cube root of 125, which would simplify into 2 to 5. So you end up getting a scale factor of 2 to 5 for these two similar cones. Now from there you can find the ratio of the base circumferences, which would also be 2 to 5. Which means you could also find the ratio of your slant heights, which, since it's a length, it would also be 2 to 5. And then, last but not least, we're going to find the ratio of the lateral area and the ratio of the surface area. So when you're finding the ratio of areas, of course, you take each part of your scale factor, raise them to the second power. So it would be in the ratio of 2 to the second power to 5 to the second power, which would simplify into 4 to 25. So the ratio of lateral areas would be 4 to 25. And then that's going to be the same for the ratio of the surface areas, because as far as ratios are concerned, area is area. So the ratio of the surface areas would also hold as 4 to 25 between the two similar cones. And that's really it for the ratios of areas and volumes. So this is it for the 3D geometry segment. The next lesson we are going to start some coordinate geometry, which is a little more algebra intensive than what we've had so far. That's kind of like if algebra and geometry got together, what would you get? You get coordinate geometry. The very next lesson itself will be on the distance formula. So I hope everyone has a great night. Take care.